All right, so let's talk about what's happening in tech right now. There's this new kind of role popping up, a role so valuable companies are throwing insane amounts of money at them. And no, I'm not talking about your typical software developer. This is the AI engineer. So today, we're going to dig in and figure out what exactly makes these people so essential.
I mean, it's the question that's buzzing all over Silicon Valley, right? $1 million for an engineer? Seriously? What on earth are they doing to be worth that much? Well, that's what we're here for. We're going to break down the skills, the mindset, the whole shebang that makes up this new kind of builder.
Okay, first things first. We've got to wrap our heads around a huge shift in what it even means to be an engineer. The job itself is changing at its core. We're leaving behind a world of predictable, easy-to-follow rules and stepping into a world where everything is about managing probabilities.
So this is really the key idea. Think about regular software, right? It's deterministic. You put in X, you get out Y every single time. It's predictable. But AI systems, they're totally different. They're probabilistic. You put in X and the system kind of guesses the best output based on a whole lot of statistics. So the engineer's job isn't about writing a strict set of rules anymore. It's more like being a coach, shaping and guiding the behavior of this probabilistic system.
And this really lays it all out side by side. Over on the left, that's the world we all know, traditional software engineering. You're building stuff that's predictable, you've got clear logic, you can test it easily. But on the right, that's the new world of the AI engineer. They're not just writing code to pass some simple test. No way. They're building these incredibly complex systems just to measure the quality of an AI that's learning and acting all by itself. It really is a massive shift. You go from being an architect with a perfect blueprint to, I don't know, a guide for this super powerful but kind of unpredictable explorer.
You know, this quote just nails it. It's from a guide for interviewing AI engineers, and it says it all. It used to be you had researchers over here doing the math and engineers over there writing the code. Two separate worlds. Well, that wall between them, it's completely gone. Today's AI engineer has to be both. They need to be able to read some dense, complex research paper on Monday and have a working version of it running in a real system by Friday. It's a whole new ballgame.
So this whole new probabilistic world leads us to the next big change. Think about it. If you can't guarantee what the output is going to be, how in the world do you build a product that people can rely on? Well, the answer is you measure everything. And I mean rigorously.
And listen, this is so important. The best AI teams out there, they're not just messing around with prompts. Let's try this and see what happens. That's not engineering. That's just playing around. What they actually do is build these incredibly sophisticated evaluation systems. Their main job isn't even writing the AI's logic anymore. It's building the scientific tools to measure how good, how safe, and how reliable the AI's output really is.
And when we talk about measuring, it's really a two-part problem. First, there's what we call retrieval metrics. You can think of this as the AI doing its homework. Did it find the right information? Did it get all the important facts? That's high recall. And did it avoid pulling in a bunch of useless noise? That's high precision. Okay, so that's part one. Then there's the generation metrics. After it did its research, did the AI actually give a good answer? Was it factually correct? Did it make sense? Engineers have all these complex tools for scoring this stuff, but the goal is pretty simple. You have to get good at measuring both what the AI knows and how well it communicates that knowledge.
So, if the whole job is about measurement, what does the day-to-day work actually look like? Well, it's not your typical software development cycle. It's much closer to a formal scientific experiment you'd see in a lab.
And this loop right here is the core of it all. It's called evaluation-driven development, or EDD. Here's how it works. First, you plan. You figure out what good actually means and define how you're going to measure it. Step 2, you build out your tests. And we're talking a ton of them, from standard industry benchmarks to really tricky scenarios that only an expert would think of. Then you evaluate. You run your AI against all those tests and collect a mountain of data. And finally, only after you have that hard data do you go back and try to improve the system. It's this constant disciplined cycle of proposing an idea, testing it, and then making it better based on the results.
Okay, but wait, how do you measure something that's kinda subjective, like, is this code any good? That's where something called a rubric comes in. It's brilliant, actually. An AI engineer takes a vague goal and breaks it down into a concrete scoring system. Like, correctness gets up to 40 points, readability gets 20, efficiency gets another 20. And by creating this detailed scorecard, they can do something that's honestly mind-blowing. They can use another AI as an automated judge to grade the first AI's work. This lets them test their systems at a speed and scale that would be impossible for humans.
All right, so that's the process. Now let's dive into one of the absolute biggest technical headaches that AI engineers deal with every single day, managing the AI's attention span, or what we call its context window.
Now, here's something that feels totally backwards, but it's true. You'd think, hey, let's give the AI more information, a bigger memory. That'll make it smarter, right? Nope. A lot of the time, it does the exact opposite. And this problem has a name. It's called context rot. Imagine you're trying to listen to 10 different people talking at once. You wouldn't be able to think straight. Well, it's the same for an AI. Too much information can poison its logic, distract it, and just plain confuse it.
So what's the solution? This metaphor just says it all. Don't send the entire library, send a librarian. The engineer's job isn't to just cram a ton of data into the AI's brain. The real art is to give the AI the tools of a librarian, to teach it how to search, how to find, and how to focus on just the right piece of information when it needs it.
And here's how the pros actually do it. They have all these clever tricks to keep the AI's working memory clean and focused. For example, instead of giving it a 500-page report, you might just give it the summary and let it ask for more details if it needs them. That's called progressive disclosure. Or, instead of pasting in a whole customer profile, you just give it a customer ID and a tool to look up the info. See the pattern? Every one of these techniques is about one thing: giving the AI just enough information to do its job and not a drop more, so you avoid that chaotic context drop.
Okay, let's pull all these threads together. What is the final package? What defines this elite million-dollar engineer we've been talking about? Well, it's this really unique mix of deep technical skill and something a lot harder to define: good judgment.
And you have to understand, just being a great coder, that's just the price of admission. That gets you in the door. The top labs, they're looking for so much more. They want people who can read a brand new research paper and start building with it, sure, but who can also sit down and have a productive conversation with a policy expert. They need engineers who think about AI safety from the very beginning, not as an afterthought. And maybe the most important thing, they want intellectual humility. They want people who know what they don't know, people who have the wisdom to hit the brakes when things get uncertain. Because in this line of work, being arrogant is a huge liability.
This right here, this quote gets to the absolute heart of the matter, the new principle of ownership. You can use an AI to help you write code, but you can't blame it when something goes wrong. If the AI wrote it, but you shipped it, it's your code. Period. You are accountable. You have to understand it, you have to test it, and you have to stand behind it. That idea of complete ownership, it's simply not up for debate.
And that really leaves us with one last big question to think about. These engineers, they're literally building some of the most powerful technologies our species has ever seen. And as they do that, standing right on the edge of the future, their biggest challenge isn't just technical, it's moral. It's figuring out how to balance that deep, powerful drive to innovate against the incredible wisdom it takes to build with restraint. What's their ultimate responsibility? Something to think about. Thanks for joining me.